We're going to move on to Alex. So Alex will touch on some interesting research published in 2020 with a quick summary of each paper and how it relates to ASD and the microbiome. Hi, Alex.
How you doing?
Here with us. I'm just going to give a little intro about you. Alex is the father of 2 beautiful children. His eldest child developed regressive autism at the age of 17 months. Alex has dedicated his time and effort to learning about the medical components of autism through practitioners, self-research, and workshops. He is the administrator of a newer biomedical group, which he hopes to grow, while sharing information and resources that have helped his child and others. Alex is a board-certified medical physicist with a broad background in biology, physics, and mathematics. He strongly believes that a parent's observation of their child's condition and specific behaviors are invaluable data points on the road to improvement. He is passionate about helping parents see improvement in ASD symptoms and behaviors, while both learning and spreading the knowledge on how to help others afflicted with autism. Please share your story with us, Alex.
Thanks so much, Jessica. I appreciate it. I'm going to share my screen here. So yeah, that was really powerful from Marsha. Kind of took me out of my element a little bit there. Definitely similar types of behaviors and experiences that we've gone through with our son. But I just wanted to say that Marsha's experience is definitely not a one-off. There are a lot of other parents that have experienced the same kind of things in terms of the fungal component. I wanted to thank Enrique very much because he spent a lot of time in putting all of this stuff together, and it's very time consuming, but it's necessary, and he believes so. So we definitely need to get this information out there so that not only the parents can understand some of the mechanisms going on underneath, but the physicians too that might not be familiar with treating autism or seeing autism patients as suffering from some kind of medical underlying condition. So let me share my screen here. Okay. Can you guys see my screen? Okay, so it looks like you can. So I'm going to go through some of the, the more kind of hot papers from 2020. It's really exciting. I feel like the last couple of years has been a real explosion in some of the research, specifically related to the microbiome and ASD. So I'm just going to touch on some of those papers from 2020 that I think that have a really big impact in terms of the research. So this first paper was really interesting. I came across it, and basically they were able to correlate the serotonin levels in the brains of children with ASD to their verbal ability. And what they basically did is they used a technique called magnetoencephalography to measure kind of stimuli responses to kind of paralinguistic external factors that kind of reminiscent with being able to speak or responses to speech. So they're able to measure the serotonin levels in the brain by using techniques called PET imaging, stands for positron emission tomography, and this is something that they use similarly in cancer. Basically, there are certain compounds that they can put a radionuclide on, and they found a particular one that correlates with serotonin. So by using this technique, they're able to map to see how much serotonin a person has in their brain at any moment. And what they're able to correlate is that children on the autistic spectrum that had autism spectrum disorder overall had much lower levels of serotonin, and specifically those that were nonverbal had even lower levels of serotonin. Really interesting. There are some implications with that in terms of tryptophan pathways in the body. You may have experienced this with your child in terms of some of the medications that you're on, SSRIs and things like that. But some of the other things that they found were that the children that they were testing that had the lowest amounts of serotonin in the brain, not only did they have worse kind of speech in terms of verbal ability, but there was also a significant delay in terms of response to stimuli. So they're able kind of to measure that response by tracking these currents in the brain in response to the stimuli, almost as if you were to be eliciting a speech. So the worst or the lowest amounts of serotonin correlated to a longer delay, and obviously it was most pronounced in the children had the most language impairment. Interestingly, there was a previous paper where they looked at a technique called acute tryptophan depletion, which is basically a technique where they're able to kind of make the state of tryptophan in the body extremely low, as if you were to deprive the serotonin. And this was done in healthy individuals. And they showed that it could induce a similar type of impairment in terms of the currents that they were measuring in the brain that were corresponding to verbal ability. So I thought this was really interesting. Oftentimes we talk about gut and dysbiosis, and we know that a lot of the serotonin that's in the body is produced in the gut. So this is kind of indirectly related to that potentially. Really interesting papers here on mycotoxins. The first paper, also published in 2020, they looked at basically many children with autism spectrum, and they sampled their stool and looked at the fungal components. So they cultured that stool, and they basically did an abundance analysis to see how the mycobiome, so not microbiome, but mycobiome, kind of compared to neurotypical children. So they found statistically significant differences between the neurotypical group and the autistic group in terms of the abundance of the species of yeast and mold. In particular, there was a species of Saccharomyces cerevisiae, which was very, very highly pronounced in the autism group. And there were some other families in terms of the Aspergillus that were also underpronounced. And if you have any experience looking at the microbiome, you might hear, Aspergillus mold as kind of a hot thing that's potentially a bad. But I think this paper was shedding more light on the microbiome as being a family of positive and negative things, similar to the microbiome. And in particular, this Aspergillus family that they found to be virtually non-existent in the ASD group compared to the neurotypical group has been proposed to have significant positive roles in the microbiome in terms of it has antioxidative stress components, anti-inflammatory components, producing compounds that are able to inhibit cancers and things like that. So not necessarily every fungal component, when we think of kind of minimizing yeast or mold, may necessarily be bad. So it kind of gives you more thought to taking an antifungal, and maybe you need to fill in the gaps after you do so. Not too different from an antibiotic in the microbiome. A second paper where was kind of a review of all of the papers where they looked at the mycotoxin exposure. So mycotoxins, if you're not familiar, are those toxins produced by molds in the body. So you naturally have some mold. You can have some mold contamination from foods, but mold tends to live in moist environments. But what they found is, in reviewing all of the literature over a period from 2008 to 2019, there was about 11 papers that went on to discuss mycotoxins in autism, and almost all of them found statistically significant high levels of mycotoxins in autistic children and autistic adults. So kind of further cementing that fungal component that needs to be analyzed, or maybe out of whack in terms of these kids and their guts. Two really interesting papers. The first paper from a group, Zaharakis, Mazmanian, he had a very controversial paper, I think in the year preceding, where they were able to show that stool from autistic children kind of transplanted into mice induced autistic behaviors. It really shed some light on the power of the toxins in the fecal matter. So this was kind of and add on to some of that research where they specifically looked at the enzymes and the toxins in the fecal matter of autistic children as compared to neurotypical children. They looked at things like amino acids and metabolites, those produced by microbial species and yeast species. And they found that there were significant correlations between specific metabolites and clinical behavior scores. Some of these metabolites were, quote unquote, toxic to the body in essence. They produced significant oxidative stress, mitochondrial dysfunction, changes in lipid profiles, and altered levels of phenolic, metabolites. So, further evidence that there's something going on in the gut, at least in the children probed in this study, and that it could manifest in terms of behaviors in the body and oxidative stress going to the brain and potentially producing some of the aberrant behaviors that you may be seeing with your children. Similar paper coming at it from a different, analysis. Not only did they look at stool, but they also looked at urine of autistic children as compared to neurotypical children. And they looked at specific pathways of detoxification and enzymes. And the way that they kind of analyzed some of the research is they looked at autistic children that were closest in proximity to their neurotypical equivalent in terms of detoxification pathways. So you can imagine there's so many metabolites being produced in your urine and your stool, and it's probably very difficult to kind of get an understanding of what is positive, what's negative when you're dealing with thousands of metabolites. So they tried to pair the differences between the closest neurotypical child and the closest autistic child in terms of what of the enzymes they were producing and some of the metabolic compounds released. And then they looked at the differences between them. So they looked at the similarities and looked at the differences. And specifically, the differences were primarily in pathways like folate and pyrimidines. They found significant differences in yeast pathways with respect to the Krebs cycle, which is very important in the body in terms of methylation and detoxification. So there were significant abnormalities between the neurotypical group and the autistic group, further indicating that there's this inability to detoxify in the autistic group. Two papers came out of the same group. This is kind of a further analysis from the James Adams FMT trials that was originally done in 2017. This is kind of follow-up data. So what they did is they kind of went back and they looked at both serum blood metabolites and pre-FMT, shortly after the antibiotic that was given for the pre-FMT treatment, and then post-FMT, and charted some of the different changes over time effectively. And they found that basically by over the kind of 2-year period, there were significant changes in some of the amino acids, very important amino acids, cofactors, lipid metabolism, some of the many things in the previous study that were found to be statistically different. So they found significant changes in those pathways by basically transplanting the microbiome from, quote, unhealthy person into an autistic person. And they showed that not only were there changes, but they more closely resembled neurotypical pathways, and they were able to be held. So these are important pathways in terms of detoxification and just understanding in the body. Excuse me. So I wanted to kind of, jump off topic a little bit and talk about FMT because it seems to be a hot thing. It was used in the initially in that James Adams study. There was some nice research that came out of 2020 with respect to FMT. The American Gastroenterological Association released a very important report on the safety and efficacy of FMT, specifically with respect to C. diff. It was really great because it showed that there was very, very little side effects in terms of, complications. But not only that, 90% of the people that were affected with C. diff that received the FMT were basically cured. And these are people that had recurrent C. diff that were unable to be treated with antibiotics. So it really is helpful in terms of, making a case to the FDA that this is a therapy that needs to be approved and further researched in this country. And I think it's going to be a big tipping point for potential therapies for ASD in the future. Not only that, even though these next 3 papers don't have anything to do with autism, what they show is that the concept of FMT can be applied to other diseases, which really kind of makes you step back and think, well, maybe the gut is more implicated in many of the diseases more than what we think. And I think that if you go and you do your research on things like Parkinson's or Alzheimer's or multiple sclerosis, you will find that there is correlated issues of yeast, fungal overgrowths, dysbiotic flora. They're finding more and more every day that the microbiome is playing a significant part in these diseases. And specifically for Alzheimer's and Parkinson's disease, and there's some previous papers on multiple sclerosis, these are also neurological diseases, not necessarily too different from autism, but in terms of when they present. You can imagine that would you be able to tell Parkinson's and Alzheimer's in a child 2 years old? Would it be that too different from autism? These are obviously distinct diseases, but the point is that the gut has a significant role to play. So specifically looking at the Parkinson case, they found that many of the patients that received FMT had significant improvement in their Parkinson's symptoms in terms of scoring and quality of life. And the same doctor that Marcia was talking about that was also involved in some of the other FMT research, she published a paper where there was a rapid improvement in an Alzheimer's patient who received FMT to treat C. diff, someone that couldn't remember their wife's birthday, and weeks and months after they were being able to remember some things from their childhood, and basically their Alzheimer's disease effectively faded away over time. So this was something that wasn't expected and has been seen in the literature with other diseases like multiple sclerosis. So it basically says that the microbiome is a significant component, very powerful. We really should be looking at this in terms of the etiology of involved in autism. So I have some of the papers up here if you want to go back and read them. I was trying to do my best to keep that as short as possible. Just a little bit more about myself. We've seen some improvements with my son doing some things in terms of treating the gut, and those things are very powerful, and I know many other parents have too. Not every form of autism seems to be involved with the gut, but it does seem to play a significant component in many of the children with autism. So I suggest that if you want to help your child or your children, that at the very least try to look into this, because there may be some small things that you can do, and you might be able to see some significant improvement by doing them. And these things can be quite safe and quite benign, from nutrition to just probiotics. But I think it's we need to spread the word out and make this something that everyone knows and all the doctors knows, because it's important, so that these kids are able to heal, because they're in distress, right? They're in distress and they need help. So that's it. If anybody has any questions.
Thank you so much, Alex. We do have a couple of questions. I don't know if maybe I'll just throw you a question right now, and then maybe we'll save some other for the roundtable. One of the questions that came through from Sam and Tyler said, so in theory, if we fixed our child's gut, would that help them with mitochondrial dysfunction? Or would we still have to work on the mito side as well?
I think that the evidence shows that the dysbiosis in the gut has a significant role to play for the mitochondrial dysfunction. If you think of, basically the gut is a huge muscle, right? The peristaltic action. And if you have dysbiosis in terms of you're producing too many toxins or you don't have the enzymes to get rid of those toxins, that's going to impact the mitochondria. It's going to impact the way the peristalsis is happening. They may be constipated. You're going to have stool sitting for a long time. So I think that by doing positive things for the gut, you can see significant improvement. I don't necessarily think that you can, it might be a cure in one sense for, a particular person. There might be other things going on in someone else. But I think that there's some low-hanging fruit. And by doing positive things, and that's diet, probiotics, and, even just starting out with testing to see what's going on in there, stool testing, organic acid testing, I think it can go a long way and can be positive.
Okay, wonderful. Hopefully that answered your question for Sam and Tyler. Thank you so much, Alex. That was an amazing presentation.